In this video, we're going to cover what .NET is, what C# is, and how these two relate to one another. So whenever I mention .NET, I want you to think of three things, three components. 1, languages, 2, application models, and 3, runtime. So what are languages? I'm not talking konnichiwa like Japanese, but I'm talking programming languages, because over the many years, there have been many languages which have been created and adapted for .NET. And examples of languages which have been created for .NET are C#, F#, and VB.NET. C#, you can practically use that to create anything. F#, I don't know what it's been used to create, but I do know that it's been used for something. And then you have VB.NET, which is predominantly used in the world of Microsoft Excel. And despite knowing all these languages, how do you put them to use? Like, how do you use them? And this is where application models come in. So what is it? Application models is a pattern of components that are needed for you to create a particular type of application. Because think about it this way. If you want to create a console application, then why in the world would you need source code that generates the kind of button you would otherwise see in a web application? Because a console application, all you need is a console. You don't need buttons, you don't need a stylish elements like you would find in CSS. No, all you need is a console. So a console application will have code that is needed to make a console application. And you might know a language, but how do you know the structure, the files of a particular type of project? Because how a mobile application project will be structured and the type of code it will require would be very different to how a desktop application will be structured, and also the type of code that will require. And this is why .NET provides application models. And then we have runtime. To grasp runtime, let's start by first examining our missing puzzle piece, because .NET has given us application models, and that's wonderful. .NET has given us programming languages. That's brilliant. Now we can run our application. Revolutionary. But no, we can't. What we have right now is a frying pan made of wood. It's a bunch of files trying to pass as an application. Because for that to happen, what we need are compilers and various other tools which .NET provides. And .NET provides these through what we know as the common language runtime. So if you're new to C# in .NET, there is going to be a lot of confusion that you probably harbor in your mind, because look at the history of .NET. That is where all the confusion arises from. If you went on Google and typed in .NET, you're going to come across some very similar sounding terms, like .NET Framework, like .NET Core, like .NET Standard. These are similar sounding, yes, but they're not quite the .NET that we all know to come and love. They are predecessors to .NET. First, we have the .NET Framework, which allowed for the development of different application services and desktop applications, but the problem was they only ran on Windows. And then we have .NET Core, which allowed, with its own unique implementation, allowing for the development of applications that could run on other platforms apart from Windows. Well, other than Windows, not apart from Windows, other than Windows. So platforms such as the Mac and the Linux. And then we have .NET Standard, which provided every .NET implementation with a set of API that allowed for code reusability. So the .NET Framework and the .NET Core relied on the .NET Standard. And this brings us to one of the great advantages of using .NET. So every year we get a major release of the .NET, with the first release being .NET 5, which is a rebranded version of the .NET Core. And every even release, we get a release that comes with long-term support. So right now, the current version of .NET out there is .NET 7, well, at the making of this video. And I think in a few months, we ought to be expecting .NET 8 to be released with some great and fantastic new features. Now that we're familiar with the current version of .NET, which is .NET 7, I think this is a great place for us to have a recap. So remember, from the components of .NET which I mentioned earlier, namely the languages, application models, runtime, and also how .NET came to be from the emergence of .NET Framework to the later introduction of .NET Core before we got things like Mono. Because in this next part, I'm going to show you how you can get .NET, because this is the part that would really help you pull in those concepts together and weave them into a clear picture. So there are two ways to get .NET. You can get it through by downloading the .NET SDK on the Microsoft website. So go into the Googler, and then you type in download. Oh, it's not typing. Okay, you type in download .NET. Here it is. Wait for it to load. And then you see, like I said earlier, the current version of .NET is .NET 7. If you click on download, it should automatically download the SDK here. So it's currently downloading. And what it is, once it has finished downloading, you would open it. You would use the installer, run the installer, and then verify the installation. And yeah, basically your .NET will be installed. We are going to just give it a few seconds, let it install. Yeah, I'm probably not going to do that again because I already have .NET 7 installed. So if I go into the command line here, cmd, and I type in .NET --info, it would come up with, as you can see, I already have the .NET SDK installed, and the version is version 7. Yep. The alternative option is to download Visual Studio, which is an IDE. To put it in plain terms, it's software to develop programs. So type in here, download Visual Studio, and it would come up with a detailed instruction on how to download Visual Studio. Just click on the free download here, and yeah, you'd be good to go. It's very, very simple and very easy to do. It's been very, very straightforward. Yes. So, as I've mentioned earlier, the way to verify that the .NET is installed onto your system is to use the command .NET --info. If you would like to create an application, for example, and you wanted to view the various application models, the various templates you have to make a certain type of application, the command you could use is .NET new list, which will come out with a list of all the different templates available to you. So all of these are application models. So if you chose the ASP.NET Core Empty, you will get a web application. If you chose a WPF application, you would get a Windows desktop application. And as you can see, the third column here, you can see all the different languages available to you. This is not a comprehensive list, but these are the three main languages that are used in .NET. We have C#, we have F#, and we have VB.NET. And I think this would help you put into context what we've been discussing earlier. Okay, so I think we're ready to go into a deeper dive into .NET. Some of the concepts here you've probably heard from my previous explanation, and some would be new to you. So for example, the Common Language Runtime. As I've mentioned earlier, the Common Language Runtime is another component of .NET. And what it does is that it manages the execution of your application. So let's say you've written an application, a program, and the program is written in C#, which is one of the .NET languages, and you've written this program into files, and all of this is called source code. So all the code you've written for the program into the files are called source code. Now within the runtime, we have language-specific compilers. So C#, which is the language you've written your program in, will have its own compiler, which will be different from the compilers of other .NET languages like F#, which will have its own compiler that's going to be different from the compiler used to compile C# code. Now, what the compilers do is they compile your source code, which is the C# code you've written into those files, and they compile this source code into what is called intermediate language. And what you need to know about intermediate language is that it's machine independent code. It is not your native machine readable code just yet. And although it is binary ones and zeros, it isn't necessarily the binary ones and zeros that your native operating system will understand. And to convert it into what your native machine will understand, something that your CPU can actually execute, CLR has included inside of it what is called a JIT compiler, a just-in-time compiler, which compiles and takes all this intermediate language, all this intermediate binary ones and zeros, and converts them into something your native machine can understand, and something that your processor can execute. And it is because of the non-machine specificity of this intermediate language, it means that whatever you compile, whenever you compile a program that's been written in the .NET programming languages, you compile it into a form that can practically run on any platform that the CLR, the Common Language Runtime, has been installed, which further highlights the cross-platform capability of .NET. So there are two remaining features that we haven't yet covered that are within the .NET ecosystem. Firstly, we have the base class library, which is a collection of reusable types and classes that very helpful in performing your normal, just your common programming task. For example, if you're dealing with strings, if you're trying to group data using the collections, or you're trying to access a database, or you're just performing simple I/O operations, they're the core set of classes that are basically acts like an API that are great for accessing the system's functionality. And then we have the garbage collector, which I think is one of the greatest features of .NET, which is an automatic memory manager. So when you have an application, when you have a program, bearing in mind that memory is not infinite, every time an object gets created, there's space allocated for it on something called the managed heap. And if you forget to reclaim that allocated memory, this could cause problems and also could cause memory leaks. But that's why .NET developed the garbage collector. So basically developers can avoid such problems, and we don't have to worry and bother about memory management tasks. And yeah, that's it. That's my take on what .NET is all about. I'm OGA Dev, and hopefully I'll see you again next time. Bye.